And here we have it on the copy. Actually, in this thing that the S, that is Y, here is, and then that is support. Small t. Okay. So we have the in river pressure we know that is K. We have R. We have T. Translation. And multiply P. Okay, that is actually we have a formula. P small d equal to K multiplied with matrix R vector T and for P small d B B in image. B are image. So you get formula like that. So actually, where is K? Then the K equal to matrix 3 by 3. That is how we call the focal point on S, focal point on Y, that is 1. So here 0. Okay, here 0, here 0. And here we call S, scale, and we have 0, 0. That's all. You can't see it. You can't see Y. Okay, that's correct. We call here intrinsic. Matrix. Or we call camera matrix. Intrinsic in Vietnamese we call what? No die. It without include camera. So here we have matrix R vector C. We call intrinsic. Okay, now what? And T is here. For the ball here. If camera system identical to the voltage that we have matrix M equal to 1, 1, 1, 0, 0, 0, 0, 0, 0, and 0, 0, 0. Matrix here is 3 row, multiple column. Matrix here is 3 by 3. Then here we call rotation matrix. Here is R without rotation. And here with the T on translation. Okay, I summarize the thing about it. So, actually, very simple. The physical model we have in mathematics or in computer vision, they will hold the model right now in mathematics model. Okay, that model. They will hold mathematics model to match with the camera. So that's why in order to determine one given P, where is it on image plane, you have to know on the parameter here internal and also R and T. And then you just multiply that and you get the point here. Okay? Just matrix, multiply with matrix, and multiply with vector. And then we have where is it on image plane. But in order to multiply it, you can scale, you have 1, 2, 3, 5 similar parameter. And R and T you have, totally you have 3 by 3 with 1 in 12 parameter. So otherwise you have to little bit on or parameter here, and then you just multiply to get. But the question is how to get the parameter here. We have the process called calibration. Calibration is just matching or determining the camera parameter. Okay. Given what? Given image. Given image, right? Image captured by the camera. Okay, so that's why you have that is the idea. So for example, might be in the examination and give you the camera parameter. And I ask you to where see the point P in image given for P in word. Okay, you should complete on it. You can. Is it clear? And maybe I ask you to make also the calibration. You understand the calibration? Okay, I will tell you more detail later. Okay, but also the calibration. Calibration is just make the very simple optimization. Yeah, okay, that is the idea. Okay, for example. Actually, in July, the distance from the camera center to the image plane we call the focal length. The focal length in centimeter or millimeter in July. But after calibration, almost the camera is measured here in pixel. Okay, so the unit of here in pixel in pixel. Okay, in pixel. Okay, and let's talk about formula. I give you about some parameter for it. So you can see after calibration, you can see the focal length right now here is estimated 1,931 so on, right? Pixel. And he also is unit pixel, also unit pixel. And we don't care about it right now, but also the parameter. Here you can see that it will come. Okay. So about you can see the total application of the three model. You can see my example here. Can you see it? For example here, I'll give you about how to. Can you see it? If not, we have to capture the object surrounding the object. In this case, we have more than nearly 200 pictures. If not, we move the camera to capture around the object. Okay, we have that. You can see that. And the question is for one event. You can see for one event. Let's see about here. Here, see the picture. That is the picture. And actually, that is the picture like I saw you about here also. You can see that is the picture. You can see the picture. We capture around the camera. The image here, you can see that is, let's say, 1,000. Okay, 1,600 by 600 pixels by color. Okay, that is the idea. Okay, we capture. And then for the we put on the picture inside of inside of it together. Actually, the software it performs calibration and it knows where you capture the picture. Okay, surrounding is automatically determine where you see. Okay, and after that, it runs some algorithm to reconstruct, and then you can see for example here is reconstruct object, and then you can see you can move around here. You can see the whole picture. Right? And even you can export into the the model. You export into the model, and then you can roll like here. Export onto the map file, and then you can see ladder. Okay, that is the area of, and you can see that. So now we move to the how to determine the camera parameter. Because given the camera parameter here and here, apparently again because I know the topic is quite heavy on mathematics, really. So okay, I just worry about your final exam. So in final exam, okay again. So really, you have to understand how to the right equation. Here we call camera model. The camera will come from here to here. The matrix. So you can see camera model is a matrix. 3 row, 4 column. 3 row, 4 column. So that's why when you multiply with the vector here, and then it becomes 3 by 3. And then after that, we normalize. For example, here I give you an example. I give you an example of how to compute. Right. Let's talk about for example here. I assume that the camera system is aligned with the world system. What does it mean? It means that here will also the X camera, Y camera, and Z camera. We assume that. When we assume that, then that is the rotation and density unit and also. Again, when you can see what I mean the translation in I remember in here in Greek culture I tell you about example like 2D, right? So now you can see arm without rotation, translation. T without you move the vector, you move the C, go to O, W with that, identify. So that is the purpose of vector T. And after that you also rotate to align X with X, Y with Y, Z with Z. So that's why the purpose of arm. Okay, that is the idea. So you can see for example if you I give you about let's talk about P will equal to let's talk about F equal to maybe 0, Y equal to 0, Z for the imported right now for doing 100 for the product. And that is what we already know. Okay, that is for P. And K that equal to let's talk about for example here we have 5,000, here 5,000, here 0 because the square visible. And here we have let's talk about here it will be 400. So K equal to P by 3. And we assume that the camera system identical to the world. So that we infer that R P not equal to 1, 1, 1. Here is 0, 0. Matrix. What I mean, we just suppress the matrix with the vector. And now because it's identical, so vector equal to 0 and so matrix also unit. So you can see K multiplied with M camera MC equal to R T. That equal to, you multiply the matrix here. How many? D. Wrong multiply. Equal how many? You multiply the matrix, right? 500. 500. What do you mean? 1, 3, 400. 400. 0, 0, 0, 0. You multiply the matrix. That equal the matrix. Multiply this matrix with this matrix. Cancel the first row. What is value? What is the first row here? You take the column vector multiply with row here, and you get select only 500. And this value, you can see you get the second column you select here is equal to 0. And here you select the third one, is 400. And here you select it. Okay. And actually you can see the same. Here is 0, 500. Here is how many? 400. Right. You can verify. So you can see the whole matrix here, MC, not equal to this. So for P is mount in camera, BC in camera equal to image equal to MC multiplied with P with the that equal how many? Take note of each row we have only this is that is 100 on the first. So 100 multiplied with what? 100 multiplied with 400. Okay, because 0 multiplied 500, 0 multiplied 0, and 100 multiplied with 400, and 1 0. Okay, sum all of that. And next, that row, you multiply this matrix with this vector, right? And then you get here, you get the 2 here 0, only 100. And the last one here, okay, that is equal to how many? D1. So you have three components, but in homogeneous, so you convert into 3D, in 2D. So that is equal to, you divide by 100, so you have 400, 400, here is 1. So the pixel here is 400 and 500. And actually it's the center of camera. Okay, you can see when it push 100 around here, then it's aligned here, center. Okay. And if you want another point, you choose another point, then you choose more, and then you get the pixel. And remember here, you have to divide by 100 to go from here by multiply divide 4. Okay, that is the visual coordinate in the image. Is it clear? And any question about it? Any question? Okay. Now we have to, okay, sorry. Now we talk about the camera calibration. Calibration. In lecture we have remember the book, the lecture. Actually, you can download everything from internet, including the book and slide. But actually, the book here the slide contain all kind of so actually we have everything, but I know because it's heavy mathematics, so you have to pay more effort to understand it. And then what I mean now, calibration. In order to perform calibration, let's talk about you have to have picture. Then you can see the idea of calibration in the next slide. And see what I mean. Here, let me now use your camera to capture the picture here. And what kind of picture? Actually, the picture is like that. The jetball. And then what will happen? You have not only the empty jetball, you have to design the jetball here. Currently, what is the size exactly? Where is it? Exactly the size. For example, 1 centimeter or 2 centimeter depends on you, but you know exactly in work how far from or how size in the for each block in work. So that's why usually you have to design like a protocol or special application, because when you breathe in and then it exactly you the breather is exactly 1 centimeter or 2 centimeter, must be that is the idea. And why the jetball? Because you have to detect the corner here automatically by Ipcv, or just any application. So the idea, that is you push the camera, the jetball, and usually you here is your notation here is 0, 0 in work, and z equal to 0 also. Okay. So we mean now, actually the coordinate you can see the coordinate here you know. Okay. Where is it in work? Why? Because the sign you know, and also the z, so you play on the curve, right? The bottom shows the z equal to 0, and then the sign of here, the distance, you know, maybe each block here, for example, here look like from here to here, how lies it? Around 20 centimeters, right? So you can see in work exactly, where is it in work? Now. And the camera will capture whatever. You can capture at many of them. And if you have, if you capture 10 images and then you have 10 images, then 10 positional camera. And now you have a picture, so that's why you use Ipcv to detect the corner. And you use Ipcv on any application to detect the corner here. And now to mesh only, right? So that's why, let's talk about back to the equation method. Let's talk from here. A lot of the mathematics now you should know. S I larger or uppercase S also I, what are you? Also notation here, can you imagine that? S that in word. Uppercase in word. Lowercase in image. So in word and in image. So it looks like P and small p and big P look like here, right? I, what does mean I? We have a lot of points. Now we just count I1, I equal to 1, 2, 3, so on. And you have relation here S equal to BS, P, this is P. This is P. That is the function, And how? Now you have to know. You have to get the P. If P that is, it depends on the little K or T. So you can see how to do that. Now back to the camera, you can see here 3 by 4. 3 by 4, 0, 5, 4. I give before that I give you the value for computation, but now you have to determine So I found B1, B2, B4, 4, and so on. Okay? And then here you will study homogeneous or also in image. You multiply them. Can you imagine it? Tell me about that. Look at the whole. I think because of all of my thoughts related to machine, accept that is structure and fundamental programming, right? But in machine learning, deep learning, and especially computer vision, okay. So I know, okay, all model of student, okay, maybe worry and maybe scared about it. Do you think so? So right now you have to think mathematics is simple. If you just focus on it. Do you know this concept here? Okay. Do you know on the phone? Here we have this count 1, 2, 3 count from. And what I mean here? What is that? What is that? X here the same or not?
No.
No. Okay, tell me what is different between here and here? Notation. Here is column vector. Remember column vector. And X here is a scalar. Get the coordinate S on axis. Here is vector. So can you, by your vision, what is different? Can you recognize them? What is different? Also, what is how to recognize different? Yeah, both. Remember in the book, okay, and also on model, both lowercase, that is the vector. Both uppercase usually form matrix. Okay, usually, but in now, both uppercase also vector because it represents whole world. Okay, world is uppercase. That is you know it. That is actually that is vector, and that is column vector actually the wrong. And what I mean P1 T, what I mean P1 T? What I mean P1 first? P1 here is the same P1 here?
No.
No. Here, over there that is scalar. And here is vector. What is the sign of this vector? Contain which value over there? B1, B2, B3, and C4. And usually, why the UT? Why? You cannot write T or not T, okay? Freedom, okay, no. Why they have the QP? Because in mathematics, in linear algebra, you know, the vector usually we select one or two notation, the column or row. And I know according to my knowledge, all mode of the table and the U column vector. It means that we're talking about vector, the right column. It means that you have to write like this. But what happens if you write like this? Column. It occupies a lot of row of text line, right? This is a lot. So that's why usually I row in one row only, simple, one line. And then by the time I put this deep in that in column. Is it okay? That is strict notation, you know, strict notation. You don't write, you don't want to write, for example, T or not T random, no, okay. Because our notation is column vector. So that's why when I row in like this, I have to put transform. So here again, you know. Okay. And you can see how you get it. Why you get it? F from this out. Okay, you don't know. Look at the book. Yeah.
And then we divide because we want almost.
You get multiply divide this factor to this, and then you get this. Okay, P1TS, right? P2TS, right? And P3TS, right? And then how to get it? Why you have to divide it? You convert into the by divide by z component. Okay? So you get here in image plane. Here in image plane. Is it okay? And x, y, z here in homogeneous. Okay? Homogeneous. So you have to divide. Look at here. You divide. You can see 1, 2. You divide by 100. And then you get to the here. Here the same. So that's why you have the coordinate in image plane. So back to here, you know relation between the x, the position in world to the position in image by relation, by two relation. Are you okay? Now that you had it. Okay. From now on, I took the lecture on geometry transform. In geometry transform, you only know, but okay, right now, okay, you can see you just multiply and you get two equation here, right? And right. So okay, so one pair of point, because one pair of point, what are the pair? The position in world system, the position in image, if we are given the x, that is the point in world, and here x prime and y prime, that is the position in image. You have two relations. You have one pair, two relations. And how many variables you want to determine? That's here. How many variable or parameter you want to determine each value? Look, how many? What is the purpose now? Calibration. Calibration is determine what? Determine this matrix. Determine those value, right? How many value? 5 right now. So one pair you have two equations. Okay? One pair you have two equations. So you have to need one pair. You can see here. You're writing the matrix form. It looks like in your geometry transform. I remember I only taught you about the geometry transform. Okay, and you know this a lot. Now the symbol. You also have point. So the idea. So now you have to, for endpoint, look at the reference line we have in the geometry transform, and you have the matrix. Here the data from pair, you build a matrix. You have a parameter you want to determine, and then you have the function. And if in that, given pair, and then you build a matrix. And here the vector you want to determine. And now you have to solve the system. Okay, you solve this system. In order to solve this system, you have to use the knowledge to solve by hand, because I remember in high school, no, in secondary school, okay, we only learn how to solve the system of equation, right? Hệ phương trình, right? Yeah. But that is 2 or maybe 3, but right now you have how many? A lot more, right? So that's why you have to use computer. Okay, so you don't care about that, okay? Just use one every in number, don't find. Okay? So when you make it here, so what I tell you in examination, can you get a question? What I tell you in examination? Again, in examination, okay, just 3 or more, which more, right? You can find yourself. We also, can you get up in this session how I tell you? Can you get a question from me? Multiple choice, right? Get up. I give you the pair, right? point word, point image, point word, point image. I ask you to build a matrix here. Okay? Is it clear? So that's why you have to write here and then clear to try like this. I ask you to build a matrix. Okay? It looks like in here. I give you pair, and I ask you to build a matrix. If you do exercise in geometry transform, you know how to. Okay, now that's done. So you can see the easy. What is it? You have code P in word. You capture image, you open CV to the left corner, you have code P in the image. Now you have a lot of pair, and then you build the matrix, and then you use FVD function to solve it. Is it clear? The complete question. Okay. And FVD actually decompose into three matrices like that. Right? FVD, right? So you have 12 volume. It returns you the 12 volume. And where in what it can, where are, what it is. Because it returns 12 volume. So you have to keep. Okay. How to find the center of camera, you can see. Because you from here you have 12 volume, you are ran into the matrix 3 by 4. Okay? 3 by 4. And you can see how to find center and also K or here. The center camera also satisfies the equation. Center camera. Okay? Mounted with P equal to 0. Right? P without big first. Wow. Go back to the. Can you imagine how I get it? You know that? P without this matrix. This matrix again when you see SVD right from the matrix right from system you get P. Alright? Because you get the B1, B2, B12. You are ran 3 by 4, you get this matrix. Okay? But given the matrix, what is the internal parameter or intrinsic? What is the intrinsic? Okay, now we solve. Right? But before we solve, okay, let's talk about center camera query first. Because in general, again, you have to do the center camera. Do you know why you have this equation? Center camera mounted with P equal to 0. Okay. Center camera. Center camera. Okay. That's what. Because it's the center camera, even though it's at the center, so that's why it's 0, 0 only, right? Multiply. Get it? So okay, easy. So you can see. Now you have to put what is it? Here is border, here is the vector, here is 2, 0. This equation very well now. In mathematics, the equation here is really well now. What is the name of that? Matrix A multivector V equal to 0. Okay. Voila. That is just system, right? Okay. And another also matrix V equal to lambda over V. Also another also very popular in mathematics. So in linear algebra, you know. So here you know how to solve it. It is also easy. And now you can see how to solve for all K and R. You can see in we arrange, you multiply. Okay, you can see M equal to. So how? You have to deal K and R, right? So you have to deal QR decomposition. Okay, we talk about two concepts in related to linear graph. First, FVD, net QR. Have you studied about that in mathematics? We call a linear graph, right? But I believe that when you study about that time, then you don't know what is purpose and application of QR and also the FVD. But right now you have to use a lot, right? You can see, just use the API from NumPy, you can easily get it. Okay, that is the idea. Okay, that is I tell you. So I warn you about gas because here just use actually that is writing API. He also writing API QR. So in during examination, okay, final again, back to here for me. Given pair of given pair of point, right? You have to build a matrix A for me. Okay, that is. Now we have to move to the next topic, net ratio. In we call two-view geometry. Two-view related to we call the stereo camera. Here I tell you about that. Stereo. You see? Stereo camera. He two camera on a frame. The one of the topic when I did my 3D tests is related to the stereo camera to get better 3Ds, and then we detect car and the whole car. Okay. So back to here, you can see what the image. To give me that you have two cameras, two images, and two images. Can you recover 3D point from two images? In theory, can you compute the 3D point from only two images? In mathematics, you just solve. Just tell me yes or no. Here on P in work. If we capture this camera, P center the image plane. Remember because I draw in just the plane and 2D, so here image plane. The center of camera, we call camera 1. The image plane for camera 1, P focal length. In camera 2, you also highlight it in camera 2. C2, and so also image plane. Remember here is molecular. Okay? And then you can see here is camera 1, camera 2, and then if you know distance from here, and also the angle, can you determine this equation? If I get you about distance from to camera, we call by here we call baseline. Baseline distance, right? Distance. And we also have this point, we also have rotation matrix and also rotation matrix of that. Do you know how? If you don't know this angle, can you compute it?
Yes.
Yeah, in mathematics. Okay, so in mathematics, it related to geometry. So that's why we have to learn geometry. In geometry, we call it. But the question here is, okay, if you know like that, for the possible, if the camera here is image plane, and here is the camera like that, principal image plane. Here, remember here image plane without the image. image. Actually, that is truly put error here in body. So in order to compute to determine here, you must have the center balance. Usually fix the camera of it. But what to do? In order to determine here, you must determine the corresponding deep point with deep point. We call what? Corresponding point. Can you imagine that? So imagine that there are two images from two cameras. You have the most important, you have to determine the point, which point corresponds to this. Okay. When you ever determine, and then you can either to build this. Okay. Where is it? That is the idea one we studied today. So that is related to triangulation. Triangulation. What is triangulation? Okay. What is it? Triangle. Okay. Here triangle. And then using this kind of relation to determine the 3D point here, we call triangulation. Triangulation. Okay. Even we call point. Okay. If that is related to this triangle, point P. P work. Camera C. Camera C1 C. You have to use the geometry and then you determine what B we call the triangulation. That is easy. Okay. Look at about focus on here because this topic is not optional, compulsory, but also contained in the final result. And I know that because you have a lot of topic in the computer science, but the person select topic in computer vision, even that must be a strong background. On the topic here is very simple in mathematics, but actually it has a core understanding. Okay, I tell you about that, right? For P triangulation, you know only that is. So I skip. Okay, skip that. But actually, in theory, you also have camera 1, camera 2, and then 2 points corresponding must be intersect at this point, right? But usually in practical, there are some gaps not intersect. Do you know why? In theory, it must be intersect at one point, but in practical or 50, usually there are some gaps not intersect. Why? Why? According to the law of physics, mathematics, and mathematics, it must intersect at one point. But really, in practical, during computation, it may be some gap. Do you know why? Because there are some error during calibration. Okay? Because exactly, in theory, given for B, you must know exactly where is it in image plane. But there are some error during calibration. And one more, because image plane after rudder line that is the decrease, not continuous. So that's why actually that is there are some gap. Okay. And sure you know only P1, P2, maybe 2 cameras. Here matrix of camera 1, matrix of camera 2. Okay. In image world and that here. Now, what I mean, you have to determine this. Okay, you have to determine calculate where is it given camera and given the corresponding. Given corresponding, given camera, and you have to determine this. We call calculation. And then you can know only. Okay, under that you know only S small equal to PS. Again, in world multi with camera equal to image plane. And then S in image plane. And now you know this, you let S. Okay. And usually in practical, in here, but usually in practical you can multiply with alpha, any alpha. Do you know why? Junior. It means that when you have the equation, you also have the equation. Why? Because it related to the zoom scale of camera. So otherwise you can multiply the zoom. Okay, now what you know and what you don't know. You want to compute BW without this. Given what? Given here and given camera. But not only for one camera, two camera. So otherwise, here this point in camera 1, another similar on camera 2. And the camera matrix for camera 1 and also camera 2. And then you have to given this one. And that is the problem. And okay, now we have become okay, so I also review you about mathematics. Look at both. The review about problem. Okay. Cross root, even we call tích có hướng, right? How do you remember? How do you remember the vector cross root? A cross B equal to vector, not scalar, right? But how to remember the equation? How to? Something you have to know and something you have to remember. Something you need not remember. Because you have to look up on it. But if you say that, okay, you don't know, you don't need to remember anything, that is wrong. You have to know some. For here, dot, very simple only, variable dot. But now dot variable, now we have, let's say we have vector A equal to A1, A2, A3. Vector B equal to B1, B2, B3. So C equal to A dot B. Okay? So C compute like that. Okay, C equal to the depth of this matrix, determinant of this matrix, this determinant equal to vector I multiplied with that of remove this column, remove this row, we have A2, B2. Subtract from Y, for J, multiply with that, remove the column, remove the row, that is equal to. Right. And first, K equal to multiply with dot or that of remove the column and row. So A1, A2. So you can see here that equal to dot here A2 B3 subject for A3 B B2. Okay, here subtract and then make to plus that by equal to here now you can see A3 B1 subject for A1. And now here A1 B2 subject B1 B2. Okay, that is the first important method. Okay, that is the crop product. That is the vector. So the vector is particular. And remember, I want to review also the here the module of this vector equal to the area of this set, right? Very low bound. Okay. So okay, to hand concept A dot A means that the cross product between itself so equal to 0. Okay, and you also here particular also equal to 0 for now. C dot A, C dot B equal to 0, and A dot itself, okay, any itself, okay, equal to 0. Why they have to be because next you have to use. Now look at the ball. Look at the ball. When talking about multiply cross product between two vectors, now the transform into multiply between matrix with vector. Okay? How it becomes vector, but they transform into linear transformation here. It is that it is equal to matrix multi-vector. How to build matrix? The build like this. Okay? Okay, you can see. So the given notation, okay, that is very, very strange for your own job here. What do I mean here? You see B. What does it mean? It means that you build a matrix from vector A, okay, for cross product. Here is not operator. Here is just simple. Okay, you can see now here notation here. You build a matrix of cross relation based on A. Very simple. That is okay? Okay, that is just notation. You accept because if you don't listen, then I forgot. Sometimes people, okay, what is it that is operator? No, okay, that is just the matrix. Here, that is because they want to transform the product by using matrix multiplicator. Okay, now you have this relation. Now okay, back to translation. You have this equation only. Remember, we want to determine. I will go right now into the net. Given this and this. Okay? And why? Because you can see here you move to subtract to equal to 0, right? You can see you can transform to this easy. Okay. So now, then beyond this, you have equation only. Because why? Did you remember this? Here is equal to matrix multiplied with matrix. Okay, that is like why they transform into the corrupt? Because they apply matrix multiplied with matrix. Okay, you can see that on to here right now. Get it? Right? You had only similar. You had it, right? You had it. Now, again. Now you can see that equal to this. So right now you have it. So you can see again. Cross product now become matrix multiplied with vector tend to this position. So that's why after you multiply, you get this matrix on a this vector. Okay. You identify the on the right side that is 0 vector. Now you have system only. Okay. And you can see 3 rows. But the third row can the linear compression of 2 rows. The first 2 rows, otherwise you remove this row and you get only this. It means that one pair you get 2 equations. Okay, that's 2 equations. And now you add a complex into many pairs to get the system right now. So again, on the duration back to the solving system. A function, okay? Now the question is how what I asked you in 5%. Okay. Again, because now when you build a matrix A and you have S, I'm sure you don't know to use the pivot and using programming. So I don't ask from now on. I ask how to build matrix A. Okay. how to build matrix A. Again, read this slide and then try to use like that, look like before. Okay, now you just show it by idea. Okay. Okay, that is triangulation. We stop here for triangulation. Tầm nhất quá. I'm sure I know. A lot of symbols, so that's why you also had that too. But I believe you have slide, you have book, and then you pay a lot of time, then you can understand this. Because when we have A at equal 0, okay, just give ABR to solve, okay? So that's why I just ask you about how to build matrix A. Okay. Any question about it before we go to the next topic? Good. Yeah. Yeah.
That's it.
Yeah. Yeah.
So how do you convert from both equations to no equation?
You mean not from why you get this or get this?
Yeah. How you get the one from?
The first one. The first one because you had the relation before. The first one. Back to the original slide. Okay. Here, camera. You had it? Okay, first. Here in word, here camera, here in image plane. I told you before, we saw that before, right? But why you interior in alpha? Because actually, any satisfied with any alpha. Why? Because it related to the camera zoom. Okay? Alpha zoom. Do you know zoom in camera?
Yes.
Okay. In iPhone here we also how to capture because if you capture file and then you have to zoom right? That is so that's why you can be like any of them. You okay? Any question more? So again, similar to the calibration, you have to build the system of equation. Okay? Just build. And how to solve? We don't care because we use API. Okay? You don't know how to build it? Okay for me. Okay? Maybe I give you this some pair only and then I ask, okay, the item variable because the matrix is too large. Matrix A is too large, right? So that's why I ask you about just variable some position inside only. Okay? It A, B, C, D, right? I don't ask everything here because I asked just one or two positions A. It is clear. So that's why you just know how to compute A before look like calibration. So again, right now you can see a lot of related to system of equation. You remember in chapter about geometry transform, you also have new matrix A. You will that right? Given corresponding point, and now also you have two for calibration, and also for what? For triangulation. Very clear. Now we move to the topic about actually about geometry. In geometry we don't have maybe it's too new. It's far from the knowledge in geometry, so that's why we don't have it. Okay. We have epipolar geometry. Geometry, hình học epipolar. Okay. What does it mean? Now just introduce concept, don't worry, only concept. You have camera 1, camera 2, so we call the camera center. The connection between two centers we call biolays. Here, okay. We have image plane also, you know only. Now not view, right? Not view. Now that. Remember it is triangle, so that's why we had a triangulation only, right? Now I do one more concept called epipole, double. What is epipole? Intersection of byline with image plane, we call AV1. Do you concept right? Okay, read one by one. Center, byline, image plane, intersection we call AV1. Concept only. Then we have the epipolar plane. Here. Then that is actually let here trunk plane. There. The configuration of O on image plane. Relation of O parameter on image plane. Right? You have epipolar line. Okay, now epipolar. The intersection of image plane with the epipolar plane we call the line, epipolar line. Just concept first. You have a line, you can draw, right? So you have all the concept right now. You have here L and also we call L prime. Now just remember, okay, what is the yellow, the epipolar plane. Here is row, here is line, here is byline, right? And here center camera, and here image plane. Okay, got it. Now there are some constraints. You can see what I mean constraint here. Without the not freedom, there are some constraints. We back project S into a ray 3D. What I mean? Okay, here. Now we have to back really important here. S plane go to rays. Okay, ray. Okay. We call back. Okay, one more. Remember right here important in 3D reconstruction in new ways. First of all, you can see my reconstruction object, right? Actually, that is I built on it. So the concept here is actually in order to create the image plane, you have to consider the camera. You have to push soft light from center to the point in image plane, and then point to the C3. We copy the color over there to assign it. That is if you know, if you study computer graphics, then it's less than that. Okay, that is the software like right. So you can see here. Look at what is this constraint. Here. Here you have if you fit them, if you have a right fit, and also fit, you have a right. Right? So corresponding on this side, camera side, you can plot the many lines from it. But only one line, okay? Only corresponding to the capture the same point in 3D only one. That is constraint. If you fit one line, if you fit on this side, and then you can see a lot of points like that, okay? Consist one point only, correct only to here. Okay? For example here, if you have object around here, then you can see this pixel and this point in 3D can be seen by this camera and can be seen by this camera. So you have 2 points corresponding. Okay? Only 2. Tell me about you have 2 lines. Can be seen the same image or not the same image? Same or not? Image on of the point in front of camera right now, you have 2 lines camera, right? Can be seen by 2 camera. Okay? If I can see by left camera and left eye, and then I can see by the right eye, is it okay? Like that? No. No, because you can turn, okay? You can see, you turn on or here you can see There are some points can be seen by only one camera. Okay. So you can see only the point can be seen by two camera have corresponding only. The other there is no, right? And that is the one. Okay. Now convert. Here convert. Convert what I mean? Two principal assisted camera intersection together. Okay. One. When convert, you can see the epic point, epic line. Okay. Like this also convert. Okay. To the epic point. Intersect at epic point. Okay. Now you can see from convert on model. Your eye convert or not? Two principle, your eye convert or not? No. Exactly parallel perfectly. Okay. So you can see when convert you have the Ebola line intersects at one point. Maybe inside or maybe outside. Maybe inside here or maybe outside like this. But intersects at one point. But đó là convert. Parallel what I mean? When the principal assisted to camera is perfect parallel, you can see then Ebola is what is the feature of Ebola line? Parallel together. Okay. Look at that. What is the property of that? Why you have to study that? Wow. Back to the ball. But here, look at the ball. In front of this lecture, we study triangulation. Triangulation is only to determine the point in the 3D based on the camera which is, and also the corresponding point. Given corresponding to then, yeah, triangulation. But even after you have to determine corresponding. Okay, let's talk about we have two images. For a camera on left or camera on right. And asymptotic is not correct convert camera. When convert camera, you can see when convert camera, it will give you a point on left image. It will give you a point on left image. How to find on right image? Because you have to determine the corresponding, right? If I have point P on left, in order to determine the corresponding to the 3D point, okay, actually, you have to determine here where is it on right, corresponding. How to search for P on right? How to search for P on right when camera is what? Is confirmed. You should everywhere on right. At least maybe some line, but you don't know why. Maybe some line around here, maybe everywhere. Right. It convert. Now question, if what happens if the camera is parallel? How to search for corresponding? If camera is parallel, you can see perfectly. So the on here the epibola line parallel, also parallel, and here the same row with here also. Okay, if that is correct from two camera is the parallel axis, right? Then the epibola line must be the parallel same. So I give it a point P on this side, P on left, where to search for P on right. Only this zone, right? And for example here, correct here is S equal 0 and here also S 0. You search on left of S 0 or right of S 0? Can you tell me? Camera 1, C1. Camera 2, C2. They are parallel perfectly, right? Perfect. The image plane. Here the principle of physical camera. And there are some point like that. There is some point P onward. Here is P on left, and here is P on right. So if you know given a point on left, you should only the scan line, the same scan line. But you should on left or on right or. If there is no signal x y, x0 and x0 here, you should on left or right? On left only. Okay. So that's why if you had a two principal camera but first parallel, then you have this property. And this property help you to search for model is very fast. Okay. You search on a very small zone. Okay. So that is the idea of parallel camera. Okay. You should, right? Okay. Put a question there. You should. Usually, can I give you two camera? Can you align camera perfectly by hand? Impossible. Impossible, right? So that's why usually you just place nearly parallel, and then you compare to rectify. You made two camera equal to two camera, but they are perfectly. In that you convert to by mathematics. Okay, so that is just another topic, but actually you have to do that. So you don't worry. You don't worry about that. There are some library or some very well-known function help you to convert to camera become perfectly product on principle of it. Okay. Now again, why you study about the concept about epipolar by line, epipolar line, because it is to the corresponding solution. Because why corresponding solution? Because again, given 2 point corresponding, you can compute the what be by time operation. Okay, now the topic today here is also next here is essential matrix, and next we call fundamental matrix. So essential matrix here it will be E, so we call E matrix. The fundamental matrix we call F, matrix. Okay, next we also have F matrix. F matrix, right? And what does it mean? E matrix and F matrix. Okay, we had a constraint about the border line. Now, what does it mean? Okay, I saw you result, and then we have to rewrite the result here. Yeah. Okay. They already discovered the constraint between 2 points, or on left or on right. Related by matrix called matrix E, we call matrix 3 by 3. Here is vector in homogeneity, here vector in homogeneity, and here matrix 3 by 3. Based on constraint, they already have equal relation. Okay, that we call the constraint, the essential matrix. Get that the idea? And again, what do I mean? What I tell you about what do I mean? S and F round. So E we call essential matrix first. So F from E T. F from T, so that's why we call it E S before 0 to have the relation. Very well known, right? And what I mean S from E equal to S from usually here better, right? Remember better. Then remember here in camera system. What I mean? And E is 3 by 3 matrix. What I mean in camera system? Tell me about it. Remember, you care about the coordinate. Let's talk about. Okay, I give you an example. What is the coordinate of point P? 1, 2. When we're talking about 1, 2, P equal to 1, 2, right? Yeah. It because it related to all here. What happens if you select this coordinate? What is the same point? What is coordinate? 0, 0. So you can see the coordinate must be depend on break. So let's talk about S and S prime. What does mean camera coordinate? What is it? At the beginning, I told you 3 systems. What? Word. What? Camera. What? Image plane. Okay. So rồi. Vậy là thế. So look at the ball. See the figure here. I draw this figure. Let's see. Before I will publish one paper related to that. Okay. Remember here were the camera, the image plane. Now the black color in word, blue that is camera, and the pink color right now here in camera. Image plane. Usually for imaging process you have 3 different. And now back to here. In the essential matrix, S and S prime in camera system, right? Camera. In that here O, here Z, okay? Here O, here Z, right? And in that, you can see because we have constraint, and then now constraint is represented by the equation, right? 3 by 3. So 3 here. But what is application of 3 by 3 first? Application, you can see here. You just, in order to determine the epipolar line, the equation of epipolar line, you just get this point multiplied with E. Okay. Okay, that is the application of that. Right? In order to determine the equation of epipolar line, you just get the this point multiplied with E. Okay, that's all. Okay. So that is the idea. Here, application. Then you just multiply S with E to get the epipolar. Okay. And the similar on the other side also have like that. So here, application. E multiplied with S equal to L. If that is L, that is equal to S prime multiplied with S triple multiplied with S prime. Okay, now. And that is the compare between the homo only and the singular, right? So application again, application is you multiply the point. Okay? One of the corresponding point with the essential, and then you get the epipolar line on that side. On this side, if you want to get the epipolar line on this side, you can get this point bounded with E also, right? That's all. That is application. And here the truth of the why you get the essential matrix. Okay, here then from this line the rule up why you get that. Okay, step by step you can see. And okay, right. Very detailed. Okay, very detailed. You get it right? You put on. You get it. Okay, actually, E equal to radiation. Okay, what is this? Mình đã được cái gì một chút thì mình đã được vector And what do you mean this? What do you mean this? I told you before that around here, right? What is that? That is matrix. Okay, you build from the vector T. Okay, for crop related, and you got it. Okay, so actually E equal to here. So again, E is the essential. Actually, that is the rotation and multi-width matrix. But matrix is converted from the translation method. That is it. I tell you about application. The root is very long, so you have to reach the line at home, right? Step by step. And then I tell you about application and also what is the decompose E to T R multi-width matrix T. Let's create from T. Now, it means that E, remember, S from and here A in camera. And in camera is harder for estimation. Compare two systems were what? Camera and image. The position in image easy to determine because that is the image, then where is the pixel. So that's why you may, if the question is now it must be measured in camera. What if I reply the S here by in image plane, in image, then you have another question we call fundamental. Okay. Okay, I summarize application here for you. I see it. Application of the essential. Multi-width point on one camera, you get another AB polar line in another camera. And here also, multi-width here, you get a polar line in another camera. Okay. Now you can see, now we go to essential, now we go to fundamental. Fundamental is the same form, without the same form, without. Okay, you can see here is the result. The same form. The trick is like F equal to E equal to F. Right? But right now, another matrix here different to E. But here that S from and S right now here is image plane. An image plane. Different right now is the same. Okay, if you move here to F, then here is in what? In image plane. Okay. So you can see actually F is equal to this matrix E before you know, and K, do you remember what I mean K? At the beginning of this version, what I mean? The intrinsic camera of, right? Intrinsic camera matrix. Okay, you know. So it means that F can be computed from E. And now F is easy. Because easier why? Because you have only in image plane, you just count the image here S, here Y, and then you have the point on the inside. Okay, you have that. Okay, so that's why you have two matrices, right? And the relation between F and the relation between F and E, okay, in this here. Okay. Remember here K intrinsic camera here essential. Now the question is how to estimate F. What is after estimate F? What is application of F? Question after estimation, you get it, what is application? Back to application of F without application of E, without this equation. Very well. Here, okay. The point in image, okay, point image. not camera. Mounted with F equal to, you can refer to the cable line on the other side. Here the same. Okay? That is the most important application. Why you have to determine the cable line? Because you search for the corresponding. And I told you about, if the camera is parabola and perfect, in order to reconstruct the 3D reconstruction, okay, you have to search for corresponding pair, and then by on corresponding pair you apply triangulation, do it for 3D. Okay, you know triangulation only, but triangulation needs the corresponding point. Okay, so if the camera perfectly, then you know where you should on left side. If you want to do that, but sometimes the camera is convert, and then you should on Ebola line only, right? But if you can see. Here is not problem. So you can see here is a line, okay, and here is another line. From point here, we call P. So how to get the P from here? F prime mounting with what? With P, and you get the equation on it. Okay? And you should on it only. That is application. You know what I mean? Do you know what I mean? Because you want to, okay, you want to reconstruct to compute, to compute the point on T in 3D. But in order, you have to have triangulation, right? To apply triangulation. But triangulation only can. But triangulation need corresponding point. Okay? Corresponding point, you have to search for each image on left, you search for right. But where to search? There are two applications. If camera is perfect, parallel, okay, and after we call rectify, you can search on only very small zone. If sometimes, if the camera is the convert, then Ebola land, because you can see the constraint, the point on this line we call the Ebola line. Must be corresponding on this line only. But how to get the equation of this line? If you have matrix F, you have one P, and you can compute this, and we have F. That equation on this. That is application, right? And you should on only that line. Any clear?
So, essential matrix is used when you have the on power.
Essential matrix, okay. Sure. It's true for power and also the convert, right? But usually if the model, okay, you don't really know, okay, where to search on the other image, okay, because it's the same scan line, the same row, and on the left side, okay, but there's some convert. You want to search, you search on the draw. If in that, okay, remember AB line on two images very important. Why? Because the one point on this line corresponding only on the other line, the line on the other camera. For example, here is two AB line, right, corresponding. Then, if you search for, because you have to find corresponding, very simple. For each point on this line, to search for corresponding. But when you search the whole image is very 6 times, right? And also very error. So we search on the one line here only. But which line? But it equals. Are you okay? Is it clear? So again, I ask you about, if I give you a point on that image, okay? I give you the essential matrix, where you do the right position on Ebola line on the other camera. Okay? Or let algorithm estimate them. Okay? I give you some corresponding point, and then you have to view the matrix for me. That is the next session. That's the, yeah. So we tell you in next lesson. So we have how many good lines? 2. I reserve 1 week for review before final result, right? So actually, because conservation is too heavy, very wide area. So I just focus on some important concepts only, right? So I want to blow rational.